Hey guys, question 2 is completely separate from question 1. Okay, yeah, that graph has nothing to do with question 1. That might make sense.
Even those are something
increasing here, but then it drops down to that 32 weeks, or would you just say it's
You listed as that.
oh, you said it's really,
Yeah, you do like increasing right here.
so when they cut off, our city just put that in one section.
Because that point is now negative 0, it doesn't actually. So, yeah, it's kind of, I think it's a funky graph there. We can talk about it.
I'm a little bit confused on why she used like the hard brackets for the negative 2. No. So
I'll start erasing you.
So it's just a hard bracket.
Yeah.
So then what does it change with the hard brackets?
Oh, see, I was like, I thought you didn't, which is why I was like, okay, it's really hard to remember because which one did you have the brackets? That was the one.
That does the only
Only, but sure for now. Yes. Sorry.
Isn't the range, I mean, isn't the domain everything connected to it? It's like the only thing that's not going to go. Isn't it just such isn't it just X?
Yeah, S
I
think I'll see that.
okay.
I spit it out because I know
Give me 1 more minute here, then we'll go through it.
Yeah.
All right, guys, are we ready? Almost? Okay. 1 minute. Are we awake? 29.
Mr. Wait, what are we doing on Wednesday? I haven't gone. We're just going to be here.
No, it's our last part of skill 1. It's like function operations, so like f of g of x, all that sort of stuff, and then inverses also.
Okay, and then that's going to be posted on the school.
Yes. Yes, I've got my recording cooperating again now. It's not just recording a tiny little sliver of my screen, so yes, there will be a video of class.
Some of my teachers don't post all this stuff to school, but it's absolutely enraging when you miss a day.
Yeah, that's
Like,
hard.
they don't even have a calendar, and I'm like, well,
What's like,
sucks
what
for you,
happened?
because I'm going to be doing stuff in your class.
Yeah, that's
After
hard.
you when I come back.
I feel like it's
I can't
easier
leave
for
on time.
everyone.
I
Oh.
can't leave. So...
I think today in War Time we have the SR&R stuff. I think that's today. I think it's start watching videos. So.
Doesn't it only take like 20 minutes or whatever?
There's a bunch of videos we have to click through. And of course it's not just like one video, it's like...
Why?
So is that the same
Every year.
Is that going to cut into the Warhawk time period of class?
No, I don't think it's...
I don't know today. Because you're...
Really?
You guys are going to revolt
I'll cut you
on
off
me.
if it does.
It's done.
And that 1 minute, like when the bell rings, everyone's just going to get their phones out.
They didn't ring the bells last week on the second day, so...
When we watch that,
They're probably still working.
I know it's
All right, guys, let's go through this. Okay, so for increasing and decreasing, remember when you list those, you just use soft parentheses, okay? You don't use hard brackets on the endpoints. So where is this one increasing from? It's okay if you have multiple pieces. Yeah, go ahead.
-0, and then...
Wait, what?
Oh, wait, not negative. It's increasing... Yeah, from x is -2 to 0 is not, or am I reading it right?
Oh, I thought you said -0, and I didn't know where you were starting. Negative... So negative infinity, it does increase to 0, but we've got this like gap in the middle here with these two open circles. So we're going to say negative infinity to -2, and then union -2 to 0. When your graph is in pieces like this, guys, saying it in pieces for the increasing like this is a good plan, especially when they're both open circles. That's what you want to do. And then I have one more section. What's the last piece? 3 to infinity, if you can read my graph. Yes. Okay. Does that make sense on the pieces there? Okay. All right. Then decreasing, where's it decreasing from? And again, we'd want to do some pieces here. You could actually do this one either way. You could say 0 to 1, and then again, 1 to 3. Or since one of these is filled in, if you said, did you guys just say 0 to 3? I would take that too on this one, okay. Do you see the difference between the increasing and the decreasing there? The first one was both open circles, okay. Yeah.
Will we ever use hard brackets, or should we just be using soft brackets?
So the only time you'd ever use a hard bracket for increasing or decreasing is if it was like actually ended, you could use a hard bracket there. But otherwise, like 99% of the time, you're going to use parentheses instead of hard brackets, okay?
Okay. And for increasing and decreasing, it's like down the x value. Right?
Yes. Yeah, the y values are doing the increasing or decreasing, and you're telling me over what x values. Yeah. Okay, relative max. Guys, there's only one relative max in this graph. Did you have more than one listed? Okay, what's the one relative max? Okay, and how do we list it? Or we don't just do the ordered pair. Yeah, 1 at x equals 0. Okay, there's also only one relative minimum. What is the one?
-4 at x equals 3.
Perfect. Anybody questions about any other points, like why isn't this a minimum or max? Okay.
Why is the where's the
Right down here. You okay, Finn? We're good? Okay, thanks, King. All right, and then domain. We didn't really practice writing domain last time. So x values, we start at negative infinity. What's the first thing I have to skip over? -2, yeah, so I'm going to have -2, parentheses, -2. Now the next section goes to 1, but the 1 is included, right? So I don't have to skip over that. And then it goes to 3, another little section there, but the 3 is included. And then it just keeps going, so it's just to infinity. Yeah, are we sure? Anybody questions on that? And please don't write this one. Don't write negative infinity to -2, -2 to 1, 1 to 3, 3 to infinity. That tells me you just don't really understand what's happening with the domain. Okay? The 3 is included. There's no reason to break it up. The 1 is included. There's no reason to break it up. This is the, I just looked at the graph and wrote it down but didn't really think about it. This is, I understand how domain actually works. Okay? So this is what we need to write. Questions there? Make sense? Okay. All right, the IVT. How do we do with our bullet points? Pretty good? Okay. What do we start with? Nice, that's a freebie. All right, and then what do we get? Which one actually gave you a positive, or I'm sorry, a negative number? Did the -7 or the -2? -2? Okay, so what do I have to write then? Awesome. Yes? That's the easy one to mix up because you want to write the -7 first, but if that's a positive answer, you can't write that first. Okay. All right. So there exists a C. And then what's the inequality you're going to say with the C? Yes, I think we got there. -7 is less than C, which is less than -2. Such that, yes, yes, good job. Okay. Questions on that one? Could you do it without your notes? No? Okay, we'll get there, right? But you get the idea, it's not that hard. All right, any questions on the warm-up? Any questions on anything before we jump into them? Okay. Let me reorient here. Go ahead and get out whatever it is you are taking your notes on.
Oh my god, I remember doing that in like first and second grade. And
I was gonna
to,
say.
Like, out, like biggest mountain in your 9.
Yeah, is that like a flashback to elementary school for you guys? Elementary school?
Only fun part of elementary school was recess.
Yes.
Yeah.
Really? Oh dear. I feel like elementary school is supposed to be fun.
I have horrible teachers.
No.
I don't know who that is.
I forgot you didn't go to elementary.
Oh, shut up. We're not gonna talk about that. Shut up.
It's so bad.
That means nothing to me. I don't know who that is.
She yelled at our class for like getting like one problem. If our class had it, it was like other thing, and she would.
Thank God.
What's a class?
Yeah, and we were in 5th grade.
All right, well, now we're in pre-calc honors, so. Okay, guys, we're just doing graph transformations and then piecewise graphs today. So the first part of this, hopefully, is just a basic review. We're going to look at like your basic functions that you should know. And then we're going to talk about how we graph those with transformations, not with plugging in 7 different points, okay? So I'm going to draw several little grids for us. All right, so our first one is linear, which means the equation is y equals x. Do we know what that graph looks like? I hope so, yes. I think we all do. A line that goes through 0, 0, and has a slope of 1. All right, our next one, we're going to do quadratic. So our equation is y equals x squared. Again, I think we're pretty familiar with that graph. 0, 0, 1, 1, 2, 4. Hopefully your graph is a little prettier than mine. All right, our next one, we're going to do cubic. So y equals x cubed. Yeah, just sign out one of the passes. So for cubic, we have 0, 0, 1, 1, and then 2, 8. I don't want to put all of my tick marks, so I'll just label. It's on the back shelf back there. All right, next one. Square root graph. Okay, what does that one look like? Yeah. So it starts at 0, 0. And then we have 1, 1. And then 4, 2. that side of it. So far, so good, guys? Familiar things? Okay. Yeah, I'll wait. I'll pause a second here and make sure we're okay.
Are there just 2 more?
There's like 3 more. We have cube root, absolute value, and then rational. So 3 more. All right, let's look at the next one. So we've got cube root. So this one, this is the inverse of the cubic. So where that function is very tall and grows, this one is essentially sideways doing the same thing. So you still have 0, 0, and you still have 1, 1, but then your next point out here would be 8, 2, instead of 2, 8. Then we have absolute value. You guys know what the absolute value graph looks like? Yes, okay, good. Then we have 1 more. The rational function. Y equals 1 over x. What can you guys tell me about that graph? Anything we know about it? Asymptote, a couple of asymptotes on this one. So there's a horizontal asymptote of 0 and a vertical asymptote of 0. And then we're not going to do more than just 2 points here. It's the graph that does this. So it goes through 1, 1, and it goes through -1, -1. We'll do a whole day just on graphing rationals, but this is your basic parent graph of a rational. Okay, so now let's try to do some graphs. Let's see if I can pull up a little grid for us here. Okay, guys. So let's do some examples here. We're going to graph y equals x plus 2 cubed minus 3. The way we're going to graph, we're not going to plug in points and figure out if x is this, what is y. We're not going to make a big table of values. We're going to think about what the parent graph looks like, and you can even plot those points. So this is the cubic graph. So I'll do these in blue. So that was the one that went 0, 0, 1, 1, and then 2, 8. And if you don't get that, the 2, 8 and the negative 2, negative 8, that's okay. Just general shape here. I'm not going to connect those, I'm just going to plot them. Okay, transformation-wise, so x plus 2 minus 3. I have a horizontal translation and I have a vertical translation happening. What are they? Yeah.
The horizontal translation is 2 minus.
Okay, left 2, yep. And then what's the other one, guys? Yeah, down 3. So to graph my new graph, I literally just take each point and count left 2, down 3, and put a new dot. So I'm going to start up at the top here. I'm going to count left 2, down 1, 2, 3. Left 2. Down 1, 2, 3. Way off my graph here. So again, if you don't have like extreme points on there, that's okay, because it's a very tall graph. You can also think about sort of your 0, 0 point, just moving left 2, down 3, and then graphing it from there, if that's easier for you. Lots of ways to graph with transformations. But no tables, okay? You have to be comfortable with the transformations this year, especially when we get into our trig graphs. We'll keep practicing those. Questions on that one? Not too bad? Okay. Let's try another one. All right, how about y equals negative square root of x plus 3. I'll let you guys try this one. So think about your basic graph. And do we know what the transformation is this time? Yeah, okay. Check with each other. How's it going?
You're moving it 3 units this way and then like flips.
Yeah.
Or flips.
Okay, guys, let's look at this one. So parent graph of square root, I know, does this. Okay, that negative out in front, what is that telling me to do? Flip over which axis? I heard X and Y. What's this? It is over the X-axis. Essentially, you're saying, one way to think about it is, I could move this in front of the Y, and then your Y values have changed sign, so that's a reflection over the X-axis. So, we're not actually going to move it, but flip over X-axis. Okay, and then what about the X plus 3? What does that mean? Left 3. Now, guys, in this one, it doesn't end up mattering which of these you do first. But rule of thumb, think of it like order of operations. You would want to multiply first and then do your adding or subtracting. So a negative out in front, that's like multiplying by a -1. You're always going to flip, or if we have a stretch, do that first and then shift up, down, left, right. Okay. So flipping and left 3. So 1, 2, 3. So that's what your graph should look like. Hopefully I counted right. We okay with that? Stop for a second here, make sure we're good.
We did cube roots instead.
Oh, okay. That will look a little different.
Just a little, just a little. That'd be really fun.
No, don't do that to yourself on the test. Yeah.
Don't even select that. It's
I would actually like,
What do you mean?
I just walk out.
Sort of like that.
So the square root is just one side. Because the parent graph, if we went back to that, is just this, right? So we essentially shifted it over and then, well, flipped first and then shifted, okay? It's the cubed root that has both directions. All right, let's do another transformation and then we'll try some piecewise. Again, you guys can give this a try. Y equals negative x minus 2 quantity squared plus 4. Check with each other. How'd it go?
I'm going just
All right, guys, I'll go through it a step at a time. I just put some parent graph dots there. What does the negative out in front mean? Yep, flip over x, right?
Oh,
Okay, then what's the minus 2? Right, 2, and the plus 4? Okay. It matters on this one, which should we do first? So if you move it first, so let's say you go right to, like I'll move the vertex, 1, 2. So this is now my new vertex. If I then flip it, you're telling me your vertex is at 2, -4.
Oh, never mind.
Do you see it? This is one where
That's not what I did. I did it the other way, but I should know what you're doing first.
well, and I gave you one where you know, like,
How it's supposed to look.
yeah, like you guys know where the vertex is supposed to be on this, right? So yeah, you need to flip first. If you're flipping over the x-axis and there's a vertical translation, you need to do that flip first. So we flip right 2, up 4. So there is my new vertex, and we flipped
over to
Right to the floor.
There we go. Good? Okay, so follow that rule, guys. Do your flippings first. Just get in the habit of that. All right, any questions before we start piecewise? So a piecewise function has multiple pieces. We'll start with a linear one. You guys, I like to graph with multiple colors when I do piecewise, just so I can keep track of everything that's happening there. Okay, so the first piece, I'll stick with blue for the first piece. It says y equals -4 when x is less than or equal to -2. What does the line y equals -4 look like? Horizontal line, right? So you can kind of think of your endpoint here as -2, -4. So I'm going to go -2, 1, 2, 3, 4. Should I have an open dot or a closed dot at this endpoint? Closed, yes, because it's less than or equal to. And then since it's everything less than, I know my horizontal line is going off to the left here. First piece, not bad, right? Okay, and your second piece. You can certainly just go, oh, I know that's a line with a y-intercept of -2 and a slope of 1, and graph it from there. I also like to just find the endpoint so I know what I'm graphing in between. So if I plug in a -2 here, what will I get? Plug in a -2 into this little piece right here, guys. What do we get? -4. That's one of your endpoints. That would be an open circle. I know it's already filled in with the blue. And your other endpoint is when x is +2. What do I get there? 0. Okay. Also an open circle. Since it's linear, I can just connect those two endpoints. If it's not linear, then I have a little more work to do. So when you have a middle piece like that that's linear, you can just plot your endpoints and connect them. Okay, this last one, again, it's a linear piece. I know slope is -2, y-intercept is 4, but it doesn't start at 0, 4. It starts over here when x is 2. So I'm going to just find the endpoint and then go from there. So when I plug a 2 in, what do I get? 0, okay. Is that open or closed? Yeah, so do you guys see how that's going to fill in the little red open dot? And then you can just count your slope from there. You can plug in another point bigger than 2. It's up to you. Just know that you're going to the right now. So my slope is -2. So down 2 over 1. Here's what my line should be here. A weird green. There are lots of ways to graph piecewise. You can graph like the full graph and then go in and erase any part of it you don't need. You can use slope and y-intercept. It's up to you. You can use endpoints. I don't care as long as you can graph correctly, whatever makes sense in your head. Okay? Anybody questions on this one? Okay. This is about as straightforward as your piecewise will get, just 3 line segments. That's a basic level kind of question. We will get into some trickier ones. So let's try another one that is not all linear. Anybody need this up here? Yeah, okay.
So with the third line, just the +4, so it's the y-intercept, because it just like
Yeah, so because that would be 1, 2, 3, 4. That'd be over here, right? And then this is your whole line. But I only want it when x is greater than or equal to 2. So I don't include that part. I start graphing it at an x value of 2, not an x value of 0. Okay. That's the tricky part if you use the slope and y-intercept. You're not going to actually see the y-intercept in very many graphs.
Why not?
Wait just a second here, make sure everybody's okay.
No, I don't try to do why one.
What?
All right. I think we're good.
Is the next one going to be 3 pieces as well?
No, it's just 2. Okay, try this one, guys. All right, I'm going to let you try. Only 2 pieces. Yeah, check in with each other, guys.
Oh, that's it. It's just like, it's just like this one here. Yeah, so it's like this. That's what's very.
I wonder what that was.
That is. My graphic just keep it just because it's negative.
Oh, that's all.
You would not continue because
Oh, that's the open.
yeah, I think continuously.
No, and that's. And -2. Oh, it's like here. Okay, so I think it's like this.
They're not great at getting that lot.
I'm very bad at drawing the
Okay, guys, here's what it should look like. Yeah.
So why is it, I thought it moved to the left one and then
It abs-
row, but then you, okay, sorry.
So yeah, like if you're just graphing the whole thing with the transformation, it does just shift left 1. That's sort of where that like center point of inflection is on our cubic graph. But I'm asking you for x is greater than or equal to -2. So you got to figure out where does that start, and then you can graph it from there. So you're kind of plugging in a point to figure out the end point. Also thinking about the transformation that happened to make sure you have the right shape, since it's not just a line. Okay? How do we do on this one? Good? Ready for a little trickier one? Not terrible, but a little more. Anybody questions before I scroll off of this one? I see some people writing, so let's stay here for just a second. Yeah. Yeah, if something's not sitting right with you, ask. It's fine. Yeah? Well, wait here a second. I want to make sure we're good, that it sinks in. Okay. Good, Ariel. Sometimes we need a little processing time. That's okay. We good? Okay. Let's try another one. All right, this one does have 3 parts again. Yeah, that's absolute value. Sorry.
That was -1 for a second.
Yeah, -1x plus 11. Yeah, no, absolute value.
Come on, say cheese, bro. That was so.
think this one through, guys. That's absolute value, yeah. No. It's not negative 1x plus 11.
Yeah, it's just square. That.
They got a little bit more tricky, right?
A little. Oh,
Not terrible.
no. Yeah, I'll forget it. This one is
No, absolute value. That middle one's absolute value.
Oh.
Guys, this middle one, it is absolute value. Okay?
Okay, that makes a lot more. I was like, -1, x plus 11. My graph is nothing after that. Okay, now that makes
I mean, I think that's what it is.
Well, I don't know if it's
The math space is up, okay?
And how would I know that? You would just keep going.
Hey, this looks right. This looks right.
30 more seconds, guys, then I'll go through it.
so like -7.
So you can turn negative x squared plus 4 into that.
Because that would become, like, if you had plus 11 x squared minus 4.
You're right.
Oh, wait. Right, my
That's not something.
It's a crap.
You're right.
All right, guys, let's look at it. So for these nonlinear ones, I like to plug in the endpoint just so I know where that endpoint is exactly. So when I plug a -4 into this first one, what do I get? +4. Okay. And I know that's going to be an open circle. 2, 3, 4. Okay. Then I know I'm looking left. And so I go back to the equation and think about what I know about this quadratic. So x plus 6 squared. Where's the vertex of this graph?
0, 6.
Not
-6.
How about -6, 0?
Or that.
Or that, yeah. So I know the vertex is over here, and it's something that I'm going to graph, okay? And since this is a quadratic, I know I'm going to have that point, I'm going to have that point, and it's just going to continue going. So it's a combo of like plug a point in and what do you know about the shape of this graph and the transformation. When they're non-linear, you just have to think a little more like that. So there's your first piece. We're okay with the first piece. Okay. Then the absolute value piece that you didn't realize was absolute value. I'm going to plug in the two endpoints just so I know. So what do I get when I plug in -4 here? -3, yep. So -4, -3, and that one's filled in. What about when I plug in 0? What do I get? -1, and that's an open circle. Now, it's obviously not that graph, right? It's not just those 2 points connected. This is an absolute value. So again, we can think about the vertex. Where is the vertex of this graph?
-1.
Yeah, because it got shifted left 1. So I know this point exists. So I can connect, maybe. And there's my absolute value. Okay. Are we on a roll, guys? All right, let's try this last piece then. I'm going to plug 0 in. What do I get when I plug 0 in? 4, and that's a filled in dot. Okay. What do I know about that point? It's going. Is that the vertex of my parabola? It is, yes. So I know I'm just graphing the right half of it. It's going to be something like this. Yeah? Okay, good. Yay. All right, we can graph piecewise. You're mentally done? We're only doing one more, and you don't have to graph. You have to write the equations of the piecewise graph. It's not a complicated one. I won't make it terrible for you. Any questions on this, or anybody need this up here before I scroll away? Okay? All right.
Wait, so we're writing the equations now?
Yes. So you are going to write.
This is like, it's Monday morning at 9, it's Monday 9 a.m.
What's a 4-day week? That's the only thing
I
I feel like I've been here for 3 months. It's been 5 days. It's 4 for me.
no, we
Oh, that's a terrible point.
It really is.
I'm going to redraw that part. Okay, guys, it's pretty basic. Write the equations of it. Can you do it? No, I can't. You're just right away. Nope, can't do it. Yes, you can. So you just have to come up with what are the equations and where do they have them?
This is the last one.
Last one? Oh yeah, you can't fit anymore. This one is 1, 1. That is 1, 3, and then 2, 5. 0, 0.
so,
Yeah, okay. Yeah,
So that is a parabola, right?
that is a parabola. Not the easiest to see, but there. Again, not too complicated an equation. Much easier than what you just graphed. All right, guys. Anybody want to give me one piece?
minus 1.
Close, but no. Theta.
X squared with the comma, and then x is less than or equal to 1.
Good start. Yeah, that left piece, it's just regular parabola. It's not shifted at all because the vertex is still at 0, 0. Do you see it? Okay. And then it is when x is less than or equal to 1. All right. 2x plus 1. There we go. That's it. Yay. Okay. Questions at all, guys? Yeah. Yeah. But you'd have to do like what all did you say?
The actual value to the x, and then x is greater than
So you'd have to have, you're missing the vertical shift there. Plus 1. Yes. And then yes. All right, guys, that's the end of notes. Your homework is math space. It is posted. Start. No crying.
Tomorrow night.
Due tomorrow night. I will also post the second attempt.
Did you see when I submitted my thing?
Was it like 11:58 p.m.?
It was like 11:06.
11:56.
And guess
You
what my
got so
score
much
was?
room to spare.
Guess what my
100?
81%.
Squeaked it out.
I didn't need help. I got it to 81%.
So, Zach?